Hi guys, so today we're doing absolute value inequality, so let's get started. So consider the following absolute value inequality. So this one here is the absolute value of x is less than 3. So before we talked about how the distance from 0 is less than 3, right? That this absolute value is talking about distance from 0 is less than 3. So where is it where a distance is of 3? So if this is 0, 1, 2, 3 away. Okay. And then we can also do the left side, 1, 2, 3 away. Okay. And then if we think about where the distance is less than 3, we can see that all of these numbers here have an absolute value of a distance less than 3. Right? So for example, let's pick the number 0. Right? So let's test a point here. So let's see. I'm going to plug in 0. Let's see if this is true. Okay? So absolute value of 0 is 0. Is 0 less than 3? Yes, it is. Right? And so you can see that's why I shaded this middle section. Okay, what if we picked a different number? Okay, so let's say I'm going to pick 5 here. Okay, and I'm going to plug it in for x. Okay. Is the absolute value of 5 less than 3? So absolute value of 5 is positive 5. Is 5 less than 3? No, it is not. That is why this side is not shaded. Okay, so let's test another point. Let's test negative 7, for instance. Okay, so plugging in negative 7 for x. Right. When I do it, absolute value of negative 7 is 7. Is 7 less than 3? No, it is not. Right, so the only section where it was true was right here in the middle. Okay, so let's do the next one. So absolute value of x this time is greater than 3. So this time, I want a distance from 0 that is greater than 3. Okay. So we already know distance of 3 away, 1, 2, 3. Distance the other way, 1, 2, 3. Right. We're going to test our points. So I'm going to test, let's do the same numbers. So this time I want 0. So absolute value of 0, is it greater than 3? Okay. So this is 0. Is 0 greater than 3? No, it is not. So that means I'm not going to shade in the middle. Okay. Let's pick another point. So let's pick 5 again. Okay. So absolute value of 5. Is that greater than 3? So absolute value of 5 is 5. Is 5 greater than 3? Yes, it is. So that means I'm going to shade on this side, or this interval. Okay. Then let's test a point here. Let's try negative 7 again. Okay, so I'm going to plug it in for x. Absolute value of negative 7 is 7. Is 7 greater than 3? Yes, it is. It is true. So I'm going to shade on the side where negative 7 is. Okay? All right. As you start doing more, you're going to start figuring out a pattern. Okay? So let's do the next one. Okay? So let's solve the absolute value inequality, 5x minus 2 less than 3. So again, first, we need the absolute value by itself. Is it by itself? Yes, it is. Okay? Then, once it's by itself, I'm going to split it into 2. So here, 5x minus 2 is less than 3. Okay. And then we also have the other side distance, so the negative of this, 5x minus 2, less than 3. Okay. And we're going to solve. Okay. So the first thing I'm going to do is I'm going to add 2 to both sides here. So add 2, add 2. Okay. Negative 2 plus 2 is 0, so leaving me with 5x. 3 plus 2 is 5. Then I'm going to divide by 5 here, and I get x is less than 1. Okay. Then I'm going to do my next one. So I'm going to get rid of the negative sign first by dividing that side by negative 1. Okay. What this does is it changes this to, gets rid of the negative. Now it's just 5x minus 2. 3 divided by negative 1 is a negative 3. And then because I divided by a negative, this less than is now going to turn into a greater than. Okay? Then continuing solving, add 2 on both sides. Okay, this gives me 5x greater than negative 3 plus 2 is negative 1. Okay, and then I get rid of the 5 times x by dividing by 5. And here I have x is greater than negative 1/5. Okay? So let's graph it and then test. Okay. So here I have 1. This side I have negative 1/5. So let's test our number. Okay. So the first one I'm going to test is 0. Okay. So plug in 0 minus 2 less than 3. Okay, 5 times 0 is 0, so absolute value of 0 minus 2 less than 3. 0 minus 2 is negative 2 less than 3. Okay, and then absolute value of negative 2, I'm running out of space, is 2. Is 2 less than 3? Yes, it is. So I know at least that I am going to be shading this area in between. Okay, so here for the 1, it's an open circle. For the negative 1/5, it's an open circle. And I know at least I'm going to be shading in the middle. Okay, so let me test another point. So let's use orange. So since this is 1, let's test 2. Okay. Sorry, it's so messy. So here now I'm testing the point 2. Okay, so 5 times 2 is 10. 10 minus 2 is 8. Okay, absolute value of 8 is just 8. Is 8 less than 3? No, it is not, so I'm not going to be shading on that side. Okay. And then let's test a point here. So this time let's test negative 3. Okay. So I'm going to take negative 3 and I'm going to plug it in. So 5 times negative 3 minus 2 less than 3. 5 times negative 3 is negative 15. Okay. Negative 15 minus 2 is negative 17. And then absolute value of negative 17 is a positive 17. Is 17 less than 3? No, it is not, so I'm not shading there. And it is just this in between. And so my answer is that x is less than 1 and x is greater than negative 1/5. Or another way, we can rewrite this as a single inequality. X is between negative 1/5 and 1. Okay, I'm going to try and be a little bit more organized when we do the next one. Okay, so here we go. So first, I need my absolute value by itself. So I'm going to get rid of the minus 8 first by adding 8 on both sides. So add 8, add 8. Okay. Gets rid of it here. So I'm left with 3 times the absolute value of x plus 6 is greater than or equal to 12. Okay. Then, since it's 3 times that absolute value, I'm going to get rid of it by dividing by 3. Okay. 3 divided by 3 is 1, so now it's just the absolute value of x plus 6. 12 divided by 3 is 4. Okay. Now that I have both of them, I'm going to split it up. Okay. And so, I have x plus 6 is greater than or equal to 4. Okay, so that's one of them. And then the other one is going to be the opposite side, so it's going to be the negative of x plus 6 and then greater than or equal to 4. Okay, so I'm going to solve it. So subtract 6 on both sides. So here I have x is greater than or equal to negative 2. Get rid of the negative here by dividing by negative 1. So I have x plus 6 now. 4 divided by negative 1 is negative 4. And because I divided by a negative, I'm going to flip that sign. Now I just need to get rid of the plus 6 by subtracting 6 on both sides. And so here I have x is less than or equal to negative 10. Okay. And so let's graph. So negative 10 here, negative 2 here. So let's test a point, okay? Oh, and these are both closed circles, because it includes the equal to. Okay? And so let's test points here. Okay, that way I know if it's an and or an or. So let's test 0. Oh, sorry, 0's on this side. Okay, let's test negative 5. Okay, so I'm going to plug it in. So 3, absolute value of negative 5 plus 6 minus 8 greater than or equal to 4. Okay, so dealing with my grouping first, negative 5 plus 6 is 1. So 3 times the absolute value of 1 minus 8 greater than or equal to 4. Absolute value of 1 is just 1. So 3 times 1 minus 8 is greater than or equal to 4. 3 times 1 is 3. 3 minus 8 is it greater than or equal to 4. 3 minus 8 is negative 5. Is negative 5 greater than or equal to 4? No, it is not. So that means I am not shading this section. Okay. So let's test another point. Okay, so it's not shading in the middle. Let's test if we're shading here. So I'm going to test 0. Okay. And then just because I don't have enough room, I'm going to try squeezing it in. Okay. So here, I'm going to plug in 0 for x. So 3 times the absolute value of 0 plus 6 minus 8 greater than or equal to 4. So grouping first, so 0 plus 6 is 6. So 3 times the absolute value of 6 minus 8 greater than or equal to 4. Absolute value of 6 is just 6. So 3 times 6 minus 8 greater than or equal to 4. Multiplication next, so 3 times 6 is 18. 18 minus 8 is it greater than or equal to 4. 18 minus 8 is 10. Is 10 greater than or equal to 4? Yes, it is. So that means I'm going to shade on this side. Okay. So then, now let's test on this side. Okay, so let's do negative 12. Okay, it really doesn't matter which number you choose. You just need to choose one on this side now. Okay. So here, right, so to make it a little bit neater for myself, like I might do something like this. Alright, so that way I know this is how I got my answers and stuff like that. Okay. So plugging in negative 12. So 3 times the absolute value of negative 12 plus 6 minus 8 greater than or equal to 4. Okay. Negative 12 plus 6 is negative 6. So 3 times the absolute value of negative 6 minus 8 greater than or equal to 4. Absolute value of negative 6 just turns it positive, so positive 6 now. 3 times 6 is 18. 18 minus 8 is 10. Is 10 greater than or equal to 4? Yes, it is. So that means I'm going to be shading on the side here where negative 12 is. Okay? As we can see, based on this shading, it is a OR inequality. And so, to write my answer, here we see that x is less than or equal to negative 10, or x is greater than or equal to negative 2, right? So we see that it's what we had before, right? But now we know that it's connected by an OR. Right? And the checking of the points helped us know that it would be an OR inequality. Okay? This one here, right? This came from here, right? And how we knew it was an AND inequality was by checking our points. Okay. So that's it for today. Have a great rest of the day. Bye, guys.